Okay, in notes 2.2, we talked about shifting them right and left, and up and down. Then we're going to talk about shrinking, stretching, and reflecting those graphs. Okay, so y equal x is x squared. We had talked about as a like this. I'm sorry, it's a U shape. Okay, is y is equals x squared. Now, what does a 2 in front, or a 1/3, or a 5/4 do? I think of it like this. If I have a balloon, okay, so say this is my balloon right here, and I take it and I make it the height of it, okay, 2 times the height. What's going to happen to that balloon? Well, that balloon will get 2 times the height, but the width of it's going to get a lot skinnier. Okay, that's what we're thinking about here with 2. So this shape here is going to get skinnier, okay? And we call that a stretch, a vertical, okay? It's a vertical stretch. We're stretching that balloon like this, which creates it, make it skinnier, okay? Now, if it's 1/3, if I take this balloon here and I make it 1/3 the height, okay? So if I make this balloon 1/3 the height, okay, a third of the height here, if I squish it down, if I compress it, okay, it's called a compress or a shrinking. If I compress it, it's going to make it wider, make it fatter. So it's a vertical compress. So it makes it, compared to this one, it would make our U wider. Okay? So what makes it a stretch versus a compress? Well, what if it was 1x squared? Would it do anything? Okay, 1 would be exactly the way it is, right? So if it's over 1, if it's greater than 1, like 2 is, it's a vertical stretch, which means it's making it skinnier. And if it's less than 1, like 1/3, then it's a compress, and it's going to get wider. Okay, so 5/4. 5/4 is more than 1, so it's a vertical stretch, which is going to make it a bit skinnier. 4/5 is less than 1. Therefore, it's a vertical compression, and it's going to make it fatter. Okay, so basically, if it's more than 1, or actually, I shouldn't say less than 1 totally. If it's between 0 and 1, okay, that's when it's going to be the vertical compress. And if it's greater than 1, then it's a vertical stretch. Okay, because we'll see later on what a negative will do to it. Okay, so if the number is between 0 and 1. Okay, so this one here, we said that this one looks like this. A 2 in front, okay, once again, a 2 in front is a vertical stretch. Okay, so if I take the balloon and stretch it out, it's going to make it, if I take this and stretch it out, it's going to look more like this. And if I compress it, okay, 1/3 is less. It's a vertical compression. I'm going to draw it out like that more. 5/4, more than 1, once again, is stretching it out. 4/5, less than 1, compressing it down. X to the 3rd. Okay, our graph looks something like this. The 2 in front, once again, vertical stretch. So we're stretching this out, makes it more narrow. And 1/3 makes it wider. More than 1, compress. Sorry, more than 1 stretch, less than 1 compress. Wider. I'm sorry, that's x to the 3rd. We'll switch these two around here. These are the x to the 3rds. Cubed root. We're going to switch all those around. Cubed root's like this, okay? With the 2 in front, once again, 2 will stretch it out. Okay, so it's going to be a lot more like this. 1/2, less than 1, it's compressing it. So it's going to be more like this. Okay, so that's our vertical stretches and our compressions. Okay, now we look at this x to the 3rd. Actually, it should be just right here. X to the 3rd is like this. Okay, a negative x to the 3rd out in front is going to flip it over the x-axis. Okay, so the negative in front flips it over the x-axis. So this part here comes, so it'll be like this, and this part here will go like that. Now at any point you can use Desmos to look at these and verify and make sure you have them right, but I want you to get familiar with memorizing these a bit. Okay. Now if the negative's on the inside, that means it's going to be a reflection over the y-axis here. Okay, so this would look like this, and actually in this one it would look pretty much the same. Okay, but wanted you to know that if it's a negative out front, it's across the x-axis, and if it's a negative on the inside, it's across reflection across the y-axis. Okay, I know in Algebra 2 you talked a lot about the negative out in front here. You didn't do as much with this one. We probably won't do quite as much here either. We'll do more with this. Okay, so here, if this is our graph, I want you to get good at graphing these things. Okay, so thinking about this. The negative in front of it, that means it's across the x-axis. So if I take these points, I want to reflect them across the x-axis here. Okay, so that's at 6 here going across. So I'm going to reflect it, and it's going to be at negative 6. Okay, so you can see that reflection down there. Okay, and this is at negative 1, negative 3. So if I reflect that, it becomes 1, 3. And then this reflection still going to be the same spot, 4 there. Okay, so that is that reflected across the x-axis. Now, if I take this reflected across the y-axis, going across this way, so this is at 2, so it would be at 2 on the other side. At 6. Okay, and this one's this way, so this will go out this way. Okay, so this point here would become over here on this side, so negative 3, down 3, and then over to 1 there. You can connect those. And then this goes up to, this is 4, so if I reflect it across the y, it'd be at, sorry, it's at negative 4, it goes over to 4. Okay, so here we have this being reflected across the y-axis there. Okay, now we're going to put a lot of that together to draw these. So this one, okay, so I know our parent function is a y equals x squared equation, which is a U shape, and it's going to move plus 5, means up 5, minus 4 on the inside moves it right 4, so there's my vertex, and it's usually a U shape, right? But it's a negative, so it's going to be reflected down, and 3 is a stretch, so it's going to be maybe something like this. Okay, this one here is absolute value, so it's going to be a V shape. Minus 4 shifts it down 4, plus 3 shifts it left 3. So there's our vertex. Okay, so usually we'd have our V there, but this out front here, the negative reflects it down, and then the 2/3 is less than 1, so it's going to be a compressing, so it gets wider. Now, if you really want to be accurate with that, you could say the slope is a negative 2/3, so you could go down 2 and over 3 and down 2 and over 3 to get those exact points if you want. I'm not going to be too picky with that. I basically want you to know whether, if it's a stretch or a compress and what, like wider or narrower. Okay, down here, x to the third, okay, y equals x to the third usually looks like this. It's going to be shifted up 4. And minus 3 moves it plus 3, so there is that point. And the 2 is a stretch, so it's going to make it more narrow. So you can kind of sketch it a little more narrower. Okay, this one here. Now, people get confused by this part here, but is this the same thing? Okay, is that the same thing? We have a plus 4 here. I'm just moving it to the back side. Really the same sort of idea, just in the form that we usually see. So absolute value is a V shape. Plus 4 moves up 4. This 4 moves it plus 4. So we have our vertex there. The negative will open down. And the 2 is a stretch. So it's going to get kind of narrow. Okay, so here we're going to write the equation. We know it's going to be an absolute value. Thinking about where this vertex is, it's shifted down 3, so minus 3 on the end. Shifted over positive to plus 4 here, so it's going to be x minus 4. And it's not shifted down, reflected down, so it's not a negative. Okay, and we can think about our slope here. It goes basically up 3 and over 1. Okay, so it's a stretch. It's being stretched out a bit. Okay, this one here, once again, absolute value. 1, 2, 3, up 4, so plus 4 on the end. Left 2, so plus 2. It's opening down, so it's negative. And it looks like it's going down 2 over 1, so got negative 2 there. Okay, those are notes 2.3.